Hello everyone, welcome back to Sai Homeschool. Please like, share, and subscribe my channel. So far, we discussed in a carbon and its compound chapter. We discussed properties. So why the carbon is unique or versatile nature of carbon because of tetravalency and catenation we studied, right? In that we discussed the tetravalency. So valency of the carbon is 4, how it will be connected with the 4 hydrogen atoms and how the bond formation around the carbon it will be takes place we studied. Then catenation, self-linking capacity of catenation we studied. Then covalent bond we studied. Then one more thing, classification of hydrocarbons in that saturated and unsaturated hydrocarbons we have discussed, right? In that, then how alkanes, alkene and alkynes it will be present. Then the number of carbon atoms if it present. So if it is the N form, so alkanes having carbon carbon single bond, alkene having carbon carbon double bond, and alkynes having carbon carbon triple bond. These things we studied so far. So now we will discuss. So we know that a carbon it will be self-linking capacity it has, that it may be in the form of chain or maybe branch or maybe rings. Okay. So in that we will study. So if the carbon chain, so if the carbon atoms arranged in the form of, so how it will be in an alkanes, carbon atoms are connected each other with the form of ring. So if it is connected in the form of ring, that is called cyclic hydrocarbon. So one example I can take here, 3 carbon atoms, it will be present. So it has two already carbon having 2 bonds, another 2 bonds with hydrogen, here hydrogen, here hydrogen. Formula of this you can write is C3H6. So name you should write. So number of carbon atoms 3 means what we will call pro. It is all carbon having single bonds around the carbon, then it is alkane. That is, it is in the form of structure, cyclic structure, that is cyclopropane. So in the form of alkane, it will be present, that is cyclic structures. So it is, sorry, then chain structures, how the carbon will be linked in the form of chains, that we will see. So if you observe here, so carbon has the self-linking capacity so that it will be C carbon, one carbon connected to the another carbon, that is chain. So it is possible like this also, it is possible chain. Then it is the branched structure. So if you take a carbon, then if you write, see here, carbon, one more carbon, or maybe you can write carbon here. So if I ask you to write cyclic structures, you should write, you can take a 4 carbon atoms, it will become like this. So 4 carbon atoms means bute. It is such structure will be cyclic structure, then it is a cyclobutane. That you can write. So and also branched form it will be present. This is the cyclic structure. This is, you should name for this, we should write it is a cyclic structure so that we can write cyclo. So number of carbon atoms will be 1, 2, 3, 4, 5, 6. 6 carbon atoms means X. Then it is all bonds around the carbon will be single bond. It is the ane, cyclohexane. This is cyclic structure for the cyclohexane. So these are cyclic hydrocarbons. These are branched and straight chain are, so here straight chain are branched hydrocarbons. Straight and branched carbon chains, some compounds have carbon atoms arranged in the form of a ring, that is cyclic hydrocarbons. So there are, so apart from alkenes, alkene, alkynes, some more another organic compounds will be cyclic hydrocarbons. These are also called cycloalkanes. So in an alkanes, the carbon atoms will be connected with each other in the form of ring. That is. Then one more thing, it is aromatic hydrocarbons. One more hydrocarbons, that is aromatic hydrocarbons. Aromatic hydrocarbons means those hydrocarbons having peculiar smell. So that we can take example for that benzene. So it has, see here, if you observe the benzene, 6 carbon atoms. So double bonds will be arranged. One single bond, one double bond, one single bond and one double bond. So carbon and hydrogens in this we have, these are also hydrocarbons. We already know what is hydrocarbons is the compounds which contain carbon and only carbon and hydrogen. So in here we can call it as, if it is the single bonds, that is saturated hydrocarbons. If it is a double or triple bond, it is unsaturated hydrocarbons. We already know if all the carbon atoms having single bond around it, it will be alkanes. If double and triple bond, it will be present alkene and alkyne. So this is the structure of benzene. They will ask you to write the structure of benzene, and formula for the benzene is C6H6. So if you observe this, it will be unsaturated hydrocarbons. These are aromatic hydrocarbons which are having peculiar smell. So next, one more important topic we will study, structural isomers. So structural isomers means, so the molecules which are having same molecular formula but it has different structures. Okay, that is isomers. So that we will see isomers. Structural isomers very important. They will ask structural isomers. Structural isomers. Structural isomers means having same molecular formula but differ in the structure. So one example I will write for the butane. But means how many number of carbon atoms it will be present in butane. So there are 4 carbon atoms. So it is there is a 4 carbon atoms it will be attached with. So it has already one bond with another carbon. And how many hydrogens it requires is, it requires 3 hydrogen. It requires 2 bonds around the carbon. So here again we have only one bond with another carbon. There is a hydrogen atoms will be here. So here all it will be present hydrogen atoms. Okay. So what is the formula for butane? So but means number of carbon atoms will be 4. Number of carbon atoms 4 and hydrogen atoms, if you observe here, how many hydrogen atoms it will be present here is 10. So formula for butane is C4H10. C4H10. Right. So what are structural isomers? Same. Molecular formula will be same. But different structural formula. That is, so if you write the structure here, see, so 4 carbon atoms. So I will write 1 carbon in the form of branch. Okay, this is. So if you observe this, it is having 3 hydrogen atoms. It is having only 1 hydrogen atom. It is also 3 hydrogen atom. If you observe this picture, there is same molecular formula but different structure. So if you write the formula for this, so how much you will get? CH3. CH3, first it is CH3, then CH2, 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 CH3. Same thing here. Instead of coming here CH3, what will happen? Here you will get a branch structure. So this is the structural isomers. So this definitely they will ask in the exam. Then if you coming to the functional groups. So functional groups are also one of the important topic. If you know the functional groups, you can write the name of the organic compounds very easily. So functional groups means the groups which decide the chemical properties of the organic compound. So this group, so organic compounds what we have that contain hetero atoms present in the some groups. So hetero atoms means we know first above we studied what, so organic compounds that is having only carbon and hydrogen, right? So here along with that carbon and hydrogen, another elements also present in organic compounds that is oxygen, okay, nitrogen, chlorine, fluorine, bromine, iodine. These elements also present in the organic compounds. These elements we will call the heteroatoms. So if the organic compound contain these heteroatoms, then how we should name for that compounds that we should study. So this is very important. So you have to know the functional groups. So functional groups it will be present will be fluorine or maybe bromine or fluorine, oxygen, like that it will be present. So we'll see, we'll observe some functional groups. So, so what are the compounds it will be present? Chloro or maybe bromo. So functional group for the substituents will be chlorine or maybe bromine. So how we will attach this to the organic compound? So if I take one organic compound, what we will do is we have to replace any one hydrogen atom with this functional groups or hetero atoms. So functional groups will be attached to the carbon chain through the valency by replacing one hydrogen atom or maybe atoms. So one or two atoms, if you remove the hydrogen atoms from the carbon atom, and we have to add the functional group. So if it is present OH functional group, so that we will call it as a alcoholic group. So if it is a COH, CHO, so that is aldehyde group, or keto group is C double bond, O is aldehyde group, COOH is carboxylic group. These names you should remember that. What are the functional groups present? If organic compound have COOH group, that is carboxylic group. So while naming the groups nomenclature, we will read all this. So you should know the basics of this organic compounds having a functional group. So if the functional groups are chlorine and bromine, then the name we should write for the compounds is chloro or bromo. So if it is having OH functional group, it is a alcohol group. So aldehyde it is having, that is CHO. Keto group it will be present C double bond O. This is very important to write the names of organic compounds having a functional groups. Then next one more important topic is homologous series. So homologous series. So homologous series means there is, so if you write the alkanes, so one after the CH3 OH, C2H5 OH, that is C4H9 OH. So all are looking, it will be similar. Is there any difference in this? There is no difference. So is there any different atoms here? No. All the atoms having same alcoholic group and all are so in the form of alkane or maybe in the form of alkene or maybe alkyne. So if it is like this, what we have to do is, so we have to find the difference between these two. What is the difference for first and second atom will be CH2. So remaining everything it will be same. Then if you come to this atom and this atom, there is again a difference is CH2. Like that. So what is here is, so organic compounds are same, but differ of CH2 in the successive members. Successive means first and second, then third and fourth. So like that you should write. So how the functional groups it will be present or not, whatever maybe if you take alkanes is also enough to know the homologous series. If I take alkanes, so what are alkanes? Carbon carbon having single bond, right? So if I take alkanes you should know first it comes methane, CH4. So here one example, CH4, and next it is C2H6. Second it is C2H6. So methane, ethane, then propane, right? C3H8. C3H8. Like that it will come alkanes. So here these are all alkanes and also there is no difference in that. All are same having carbon and hydrogen. So if you take first and second, so what is the difference here? CH2. The difference is here CH2. So if you take this and this, again here difference will be same. It will be differ with CH2. That is, so these are a series having organic compounds, same organic compounds, all are alkanes, same organic compounds, but differ of CH2. Where it is CH2 for the successive members. Successive members means first and second, second and third and fourth. So if you do like that, there is a difference will be the same for all the successive members, then these will be called it as a homologous series. For same thing you should write for alkenes. So alkenes also if you write, you will get the succeeding members having the formula C3H6, C4H8, C5H10. These will be differ with CH2. So these are called homologous series. So you should remember homologous series is very important. So homologous series. So homologous series now we've understood. One example for same thing you can write for alkenes. Alkenes it is first formula it is ethene or methane. So first member it is two between the carbon atoms it is having double bond it comes first ethene. That is C2H4. Then C3, C2H4. Then C3H6. Right. So if you observe here, what is the same organic compound, but it is differ with this to this is CH2. What is the difference here for first successive members means first and second atom is CH2. So this is homologous series. So succeeding members have differ by CH2. That is called homologous series. So CnH2n, you will get N is 2, 3, 4. You can similarly generate the formula of alkenes and alkynes also. You should write the formula and you should find the difference for successive members. So here molecular mass of any homologous series, it physical properties if you see in a series, this is so molecular mass increases in the homologous series. A gradation in physical properties you can see in that is, so this is because of melting and boiling points increases with increasing the molecular mass. So if you increasing the homologous series, molecular mass also increases. When the molecular mass increases, melting point and boiling points also increases. So other physical properties are such as solubility and particular solvent as shown as a similar like this. So based on the increasing the molecular mass in the homologous series. Then chemical properties that we will use by functional groups. How the names should write, nomenclature we will study in the next class. That is how the functional groups, if it is OH present, name the organic compound. How we should name the organic compound, that we will study in the next class. So thank you for watching.